You are sitting perfectly still, deep in thought, and suddenly the office plunges you into darkness. You have to wave your arms just to get the motion sensors to turn the lights back on. This happens because standard building management systems run on rigid rules. They operate on simple logic. If a sensor detects movement, the lights stay on. If it doesn't, they turn off. The building has no understanding of what you are actually doing. That lack of understanding carries a biological cost. This chart maps out data from the Harvard COGFX study, showing how the accumulation of CO2 and fine dust particles, PM 2.5, impairs our brains. When CO2 levels rise in a closed meeting room, human reaction times and strategic thinking drop. The flaw in current architecture is simple. The building only knows if a human is occupying a room. It has no idea if that human is struggling to focus, getting sleepy, or leading a high-stakes presentation. To fix this, the environment itself must adapt to our physiological states. We need to stop programming buildings to react to our manual commands and start designing ecosystems that understand our needs without having to ask. Measuring and responding to these biological requirements allows the living office OS to treat the building as an empathetic, living organism. To function like an organism, the building needs a nervous system. In this architecture, that is an event-driven data backbone called Apache Kafka, quietly carrying thousands of sensor signals through the walls. Sending all this telemetry to a remote cloud server takes too long. Instead, data is processed locally at the edge, using tiny, dedicated computers right inside the network. This localized processing drops the system's reaction time to under half a second. Those localized signals feed directly into the brain of the system, the Intelligent Cognitive Engine, or ICE. ICE analyzes density, noise, and scheduling data to infer actual context, looking well beyond simple temperature readings. It can mathematically distinguish between 30 people sitting quietly for a presentation and 30 people moving around for a collaborative workshop. This dynamic radar chart visualizes ICE's constant balancing act to optimize comfort, energy, and air quality. To prevent deadlocks, the system uses a strict hierarchy. Safety overrides air quality overrides the majority's comfort, and the majority overrides individual preference. By locking these priorities in place, the system ensures that a facility manager's desire to save on the electricity bill will never override the fresh air required to keep workers alert and healthy. Once the brain makes a decision, it relies on the physical muscles of the space, the smart infrastructure, to carry it out. ICE issues binding action contracts to the HVAC and lighting systems. If CO2 levels begin ticking upward during a long meeting, the infrastructure autonomously flushes the room with fresh air before the occupants even realize they are feeling fatigued. But allowing an AI to quietly manipulate the physical environment requires heavy oversight. That requires the eyes of the building, the digital twin and command center. Looking at this glowing trace path, human operators can audit exactly why a decision was made. The system records an immutable decision lineage, providing mathematical proof linking an active fan directly back to a specific sensor reading and a specific safety rule. Finally, the system needs a way to interact with the humans inside. This is the smart experience layer, an invisible, ambient interface that lives on a user's phone. If the AI dims a room to harvest natural daylight, but a worker feels it's too dark, they can override the decision. That single tap triggers a reinforcement learning loop, teaching the central brain to adjust its light parameters for that specific group going forward. The architecture continuously gathers physical data, executes a response, and learns from human pushback. The building actively tunes itself to its inhabitants' biological reality. This physical tuning raises a valid concern. If a building constantly tracks our presence to optimize focus, are we creating a surveillance state? The architecture prevents this by utilizing privacy by design at the hardware level, creating an information bottleneck. Edge processors instantly convert facial features into abstract mathematical vectors, leaving no identifiable traits. Within 5 minutes, a strict protocol permanently deletes this memory. As this thermal map shows, the building understands context without knowing who is standing there. The Living Office OS proves that technology can protect personal privacy while supporting cognitive health, providing the technical blueprint for the responsive cities of the future.